Hi guys, today we're going over gas laws. We will cover gas laws, how to solve equations, the equation itself, and the relations between them. The first gas law is Boyle's law. Boyle's law, or the pressure-volume law, states that the volume of a given amount of gas held at a constant temperature varies inversely with the applied pressure when the temperature and mass are constant. Products are constant, which means if the pressure goes up, then the volume will also go up, but if the pressure goes down, then the volume will also go down. The equation is P1 times V1 equals P2 times V2. An example, if the initial volume was 500 ml at a pressure of 760 torr, when the volume is compressed to 450 ml, what is the new pressure? Again, your equation is P1 times V1 equals P2 times V2. I would make this table down here and plug in your variables, and then just solve it right here. So P1 times V1 and P2 V2. Divide V2 by both sides, and you get P2 equals 844 torr. The next gas law is Charles' law. This law states that the volume of a given amount of gas held at a constant pressure is directly proportional to the Kelvin temperature. If you have Celsius, you just take that number and add 273 to it, and that gives you Kelvin. Pressure is constant with Charles' law. Your equation is V1 over T1 equals V2 over T2. An example, the gas in a balloon occupies 2.25 liters at 298 K, so Kelvin. At what temperature will the balloon expand to 3.50 L? You have your table, put in your variables. This one you solve is a little different because now you have fractions over. So you have the volume 1 over temperature 1, and then V2 over T2. So you would cross multiply, and then you divide V1 by both sides, and you get T2 equals 463.5 Kelvin. The next gas law is Gay-Lussac's gas law. This law states that the pressure of a given amount of gas held at a constant volume is directly proportional to the Kelvin temperature. This has a direct relationship as is the same as the other ones. The equation is P1 over T1 equals P2 over T2. An example, a gas has a pressure of 103 kPa at 25 degrees Celsius. What will the pressure be when the temperature reaches 928 degrees Celsius? Have your chart, plug in your variables. It makes it easier to write out the equation. So P1 over T1 equals P2 over T2, cross multiply, solve that, and then divide P2 by both sides. And then, divide T2 by both sides, and that gives you P2 equals 420 kPa. Combined gas laws next. This gas law combines the three gas laws, Boyle's, Charles' law, and Gay-Lussac's. It states that the ratio of the product of pressure and volume and the absolute temperature of a gas is equal to a constant. For this one, there is no easy relationships between the variables. The equation is P1 times V1 over T1 equals P2 times V2 over T2. An example, the volume of a gas-filled balloon is 30.0 L. At 40.0 degrees Celsius and 1,148 mmHg of pressure, what will the volume be of the balloon with standard conditions for temperature and pressure? Make sure you have your table, plug in the variables, which makes it easier to solve. So times all of P1, V1, and T1 equals P2, V2, and T2. Solve that out, divide, and you get V2 equals 39.5 liters. The next gas law is ideal gas law. The ideal gas equation provides a variable model of the relations between volume, pressure, temperature, and number of particles in gas. The equation is PV equals nRT. P must be ATM, V is only liters, R equals 0.0821 liters times ATM over Kelvin times mole. N equals moles and T equals Kelvin. Example: you fill a container with a volume of 20.0 liters with nitrogen gas to a pressure of 197 atm at 28 degrees Celsius. How many moles of gas are present in the container? Put in your variables, write down the equation, divide, solve it, and your answer is N equals 159 mole. Never forget your units so you know which one it is for sure. In conclusion, we covered the 5 gas laws: Boyle's, Charles Gay-Lussac's, combined, and ideal gas laws. Things to remember: the product of pressure and volume is constant when the temperature is constant. The pressure of gas is directly proportional to its temperature when volume is constant. Thanks for watching.